Alright guys, I've swapped that large angle plate out for this medium size angle plate because I know this is pretty spot on for squareness and straightness. As I said, the other one there that was out by around about 2 thou across the face, so I'm going to have to do a little clean up on that at some stage. But I've got this clocked up now. So I'm pretty happy with that. I've also run it up and down the face, and that's less than 0.02 of a millimetre, so I'm fairly happy with that. So this is going to be good to use to set up my datums for doing that line boring work, because we're going to have to change that setup over for each bore. So it's important we set up our datums and we have them pretty much as close as we can get them. So we'll go ahead and get that set up and we'll bring you back. Alright guys, we're going to set this up now for doing these 2 bores, and it's pretty important that we get them in line both in the X and Y directions. So that's why we set up datums to work from when we flip this over. So this face here is going to be my main datum, and I've got to go back 44.5 from the edge of that to the center of the bore. And then from the bottom face, we've got to come up 32.75. So they're the two. So when we flip this over, we're going to be in line this way. We just need to re-indicate that edge there when it's over on this side to come up to do our bore again. So we'll go ahead and we'll get that zeroed up and we'll make our moves. So excuse me, this is going to be a bit slow. I'm sort of walking around the camera here. So I'm going to come in 44.5. Oh, 44.5. Alright, here comes my wife with coffee. That. Let's come across our 2 mil. Zero that. Come up our 32.75. That's it. Everything's zeroed out, so I'm going to 0, 0. And just by eye, that looks pretty good. Right, so we've got our X and Y coordinates sorted out. We'll go ahead and we'll set up our boring head and we'll start doing some touching off and start doing some machining. Alright guys, we're back. I've set up my boring facing head. I've zeroed it off on this face here, not that we need that just yet. We're going to do a through bore. I've changed the drawing, as I said, a little bit to accommodate for that flush washer that we're going to use to push that bearing cup out if we need to. So I've got this set up. I haven't done a cut yet, but I'll be interested to see just how concentric we actually are. So I'll put that in gear. That's not too bad. I reckon that's within about 0.2 of a mil on concentricity. So that's not bad at all. Let's take off a bit more there. Right. Get a bit of go juice. We'll see how we go. It's a complete clean up, so we're just going to hack into this and just get it roughed out. Just shy of 33, so I've got to get to 36.5. Spring past that. The finished bore on this has got to be 42, so this 36 that we're doing is only for the clearance to get the worm through, just to back up the cup. So we'll start measuring and confirming sizes. Let's chuck this out of the way for a minute. Let's see how we're looking for our bore size. Right, I might just come back on the last cut for the bore, and then we'll start doing the opening up. So we'll get that out to size, and we'll come back. Alright, last cut. So I've got to remember this is measuring off the diameter. All my other boring heads measure off the radius, so something to be aware of. Like I said, it's been a long time since I've used this head in this way. Vibration right on the transition, but you're not going to see that because that's going to get machined out. Just have to be careful when I'm doing the bore on a bore that I slow it down. I don't want that vibration where the cup's going to be. Right, let's just see. We're looking. This is going to go. See, just touching there. That's bang on 36.5. Alright, we'll set up for the boring to fit the cups into place, and then we've got to activate the head when we've completed the bore sizing to machine it back to depth. So that's going to pan out, self-act out, and do the final cleanup. So we'll leave about 0.2, 0.25 at the seat to machine up, and then we'll set up the self-act to take that out. Alright, we'll get set up for that now. I changed that tip out, but I was still getting some pretty nasty vibrations, so I changed it out for a different type of tip, or a different tool with a different type of tip on it, and that's cutting an awful lot better now. So as you can see, no vibration there at all. And the last little bit I use the fine feed handle. So I'm taking it down to 19.8, leaving myself 0.2 of a millimetre just to clean up the face on the self-act. So I'll keep going with that, and I'll bring you back when we're sort of getting close to the last finishing cuts. Alright guys, so this is the money end, so I'm only going to try and do this with one more cut after this. Just starting to see the weld on that now, actually. Alright, so we've got exactly 0.1 of a mil to go. What I may do, I may just open this up just a touch more down to the edge of the cup, so that we're not pressing that all the way down. We're just doing the pressing on the last width of the cup itself. But I'll get this bore done first. Right. I'll give that a 0.02 millimetre interference on that. With any luck. So we've got a 0.01 interference. This will be just nice for that. Right, we'll set up for the facing, and we'll get that out of the way. Right, so we're going to set up and do this facing now. So I've unlocked and got this set up, so we'll just turn it on very slowly and we'll see how we go. Simple as that. All done. So I'll just release this again and re-engage it again. Oops, alright. Done that. Alright. So that's it, bored out and faced off. So I'll just take the camera off and give you a look down inside that. So there you can see the line there with the where that boss is welded on. You see the base bore there, so it's all worked out very, very nicely. So we'll now flip that over. I'll deburr it, flip it over, and we'll do the other side. Alright guys, we're back again. Now, I completed that bore and that facing operation on that other bearing location housing. So we flipped this around 180 degrees and we're going to set up and do the boring for the bearing set on this side. So we've already set our Y direction, so we haven't moved that. We've left it on the digi readout, but we need to clock from the base back 32.75, exactly what we did down here when it was up the other way. So we're using the same reference plane to come back. Now by rights, if everything's done accurately and everything's spot on, we should have those bores pretty much in line, ready for that worm shaft. So I'll fire it up, I'll get this centered up again, and we'll bring you back when we're about to start boring. We'll see how close we are, and then we'll come back again when we're finishing out. Right, we've got that sort of locked up there. We'll just see how central it is. I'll put it in gear. Right. Get over here. Right. One little spot there that's just not cleaning up in that first cut, so I reckon that's within juice. It'll be less than 0.2, I reckon. Let's just up a little bit further. I'll bore that through. Before we've got to come out to 36.5. Alright, well I'll continue through with that boring, and then we'll come back when we're getting towards the finish. Righto, hopefully back for the last cut. We've got 0.06 of a mil to go on the diameter, so let's take this to the last one. Just using the wheel feed on this one. Let's see how we came up on size. We can't see that. It's bang on 42 millimeters. That's just scratching through. Check it one more time. So this is the bearing that I need to be able to punch out with the worm if it needs to have any maintenance work done on it. That's the reason why we've made this a transition, and we've made the other one on the other side around about a 0.02. Yeah, that's just on or just over, just a tad over, which is exactly what I wanted it. Alright, we'll set up and we'll do the facing operation on this now, and I'll bring you back when that's all finished. Righto, so we've finished our bores. Now that small step bore, I've made that very accurately for a reason. I want to check just how parallel this actually is. So I've got a bit of precision ground bar in there. It doesn't matter what diameter it is, but what I'm doing is I'm just touching down. I know this is sort of what it is, it's rough, but let's see how we go. So we've got 33.60 that end. .61 at that end, so we've got a 0.01, if you like, taper on that. Now I'll flip it over the other way and we'll see how parallel it is in the opposite direction. Alright, so we'll flip this around 90 degrees and we'll just do a check on this one here. So once again, we're just coming down and touching to 33.7, sorry, 33.5. 33.5. Oops, just knocked the stylus. Come around here. Sorry about throwing the camera around, but let's see how we go here. 33.3. 33.4. 33.3, so that's 0.02 in that direction as well. Now, you know, I know this is sort of a rough way of doing it, but it gives you a pretty good indication as to how that looks for parallel. So you can see that line boring system, that when you're referencing off edges, the way we just did, you can get fairly accurate results. Obviously, line boring in a lathe, setting that up on the saddle and line boring through is probably going to be the optimum, or if you've got a little jig borer with a tailstock that you can set up, that's obviously the ideal way to go. But for doing these bores like this, as you can see, you can get reasonably close results. So, yep, I'm very happy with that. Standing on all the wood here. All right, so next job is we're going to get set up to do the larger bores. So we'll get set up for that next. Alright guys, just want to do a little bit of a stop and prop at the moment and sort of go through where we're up to. and where we're going at the moment. So probably the easiest way to show this is going to be on the model. So we'll just turn a few of these elements off so we can see back inside where the our little housing is. Let's get rid of that. Get rid of that. So let's just zoom up into here. So hopefully this is going to work out. So there's our crank disc that we've got working on this seal. And this is the bore that we're going to be taking out fairly soon. We've also got some clearance here that we've got for the crank disc, or for the crank arm I should say. So if I rotate that around when it decides to go, now I haven't got this constrained, so it's sort of going to be rocking and rolling up and down, but you can see the action of the crank, hence the reason for the cutout in the housing, which we're going to be attempting soon. And obviously we want to be able to lift this ram. I'll just zoom in on this a bit. This ram up and down to accommodate side cutting on a keyway, and also different center heights on the lathes. So I'm going to make a little change in the drawing. I'm just going to bring the radius of the outer position in a little bit, because what's going to happen when I do the counterbore to be able to seat this, it's going to break through into that crank disc. And I did order a seal without a front seal lip, but it came with one, and if that breaks through, that's just going to end up gnawing away on that front lip. So I'll just bring that in just a little bit, just to give us a nice clean diameter to work to. And knowing now that our plate is exactly 20mm, I'm going to sink that down another millimetre and bring that seal in just a little bit further, so that's well and truly clear. You can see that crank arm there. You can see the clearance that we've got to machine into the housing for that crank arm. So we're going to be doing the bores next. We might just take that crank disc away. Oops, wrong one. So I'll just move that up out of the way. So you can see our worm and worm wheel in there that we're going to be fitting into place. We've also got that line boring. Just take that out. Got that line boring to go as well for that bearing set that's going to sit up inside there for the worm. We've also got quite a lot of drilling and tapping to do on the face to be able to mount the slideways up for the main sliding component of the ram. And we've got a bit of drilling and tapping to do on the back here for the worm housing that's got to fit inside there. And we've got to do our level plugs as well, and our filler plug. So quite a bit more to go, but I sort of hope that gives you a little bit of an idea of where we're at and what we're doing there. So we'll continue on with this. We'll get back out to the workshop and we'll continue our machining.